Okay, in this question we have a pitcher who throws a baseball horizontally, okay, and the horizontal velocity is actually 22 meters per second, so means that you actually have the full horizontal velocity of 22 meters per second. Okay, for this situation, let's make the hand of the pitcher as the origin, and location B will be the final position where the ball lands. So for the initial position, so let me write as initial. So we have it at origin, so x initial will be equals to 0, and so the same goes to y initial. Okay, and v initial in the x direction, it is 22 meters per second, while v initial for the y, what would that be? It would actually be equals to 0. Also, the ball drops in the vertical direction, so means that it's affected by gravity. So let's set a y as equals to negative 9.81 meters per second. And what about the final position? So initial and the final position. So in the final position, I'm actually supposed to find x final, which I don't know. Seems like in question B, I'm also supposed to find y final. So I don't know this, but I do know there is a time where the ball lands. So it takes about 0.45 seconds. Okay, let's think about the position, the motion in the x direction. So in x, we have x final equals to VIXT plus x initial. Since we've set origin as the pitcher's hand, so this x initial is 0. So all that remains is the x initial in the velocity in the x direction, which is 22, times the time that it took for it to reach the catcher, and that is equals to 9.9 meters. So we have solved for question A, where it says how far were you from the second baseman. So it's actually 9.9 meters. Okay, now let's look in the y direction. So what we have is y final minus y initial equals to VIY times time plus half AT squared. Okay, we know y initial is equals to 0 because it's at the origin. Also makes my life easy. VIY, the y initial velocity, is also 0. So therefore y final is equals to half A, in this case is negative 9.81, times t squared, which is 0.45 squared, and that gives me negative 0.99 meters. Notice that in the equation, the value that comes out gives me negative 0.99. That's correct because we've set the origin at the pitcher's hand. So notice that the ball will drop below the origin, so hence the negative. It actually goes in the downwards direction. Okay, so that solves for the answer for question A and question B.